Okay, everyone, I can't believe we finally made it to the last problem of our practice test. So here we're going to look at free response number 4, which involves laying down a pipe across the river and the cost of laying down the pipe across the river, like a fuel pipe or something like that. Maybe they're transporting natural gas. I don't know. But in any case, if you remember the zombie biathlon problem that we did in class, this problem is very similar to that. So let's go have a look and we'll finish up our practice test. A utility company wants to deliver gas from a source S to the plant P across a 3-mile wide river, and P is located 5 miles downriver from S. Of course, it's more expensive to put pipe down in the river, so that costs $4 per foot. And of course, on land, it's significantly less. It's only $2 a foot on land. So refer to the diagram on the right. So let's lay down our, no pun intended, or maybe pun very intended. Let's figure out how far across we're going to lay our pipe in the water. Actually, before we begin, I noticed that there is a mismatch here with units. We've got feet here and miles here. So we either need to convert feet to miles or miles to feet. I think I'm going to turn those rates into in terms of miles. So $4 a foot, that's equal to, let's see, 4 times 5280 is, that's 21,120. $21,000 per mile. Wow, that's kind of expensive. Which means $2 a foot. That's going to be equal to, well, I guess I just have to divide by 2. So 1,056 dollars per mile. Okay, everything is now in terms of miles, so we're ready to do this. Question 1, how far across the river is it from S to T? So distance ST, so across river.
I don't know that one.
ST, how long is that? So the distance, that's going to be equal to, well, that's the right triangle here, so our good friend Pythagoras will help us. The distance is going to be the square root of u squared plus 3 squared. Remember, we're doing everything in terms of miles. And so cost across the river, that's going to be equal to 21,120 multiplied by that u squared plus 3 squared. How about across the land? On the diagram, that's TP. The distance, well, if we go u miles across over here, this distance right over here, I should do that in blue. This distance right here, that's just going to be 5 minus this u part. So my cost is just, what was that? $10,560 per mile multiplied by 5 minus u miles. So we have our two costs, and now we can get our master cost function for part A. Cost is going to be equal to the sum of 21,120 multiplied by this radical expression, u squared plus 9, plus, and this is going to be 10,560 multiplied by 5 minus u. So that's part A, the cost of laying down that utility pipe, gas pipe, right? Part B, we're going to minimize this cost, which means we're going to use a candidate test. So let's talk about U. Over here, U could be equal to 0. And in that case, the pipe goes straightways across the river, 3 miles, and then across the land, total of 5 miles. So that's 8 miles worth of travel. That's probably the long way, actually. The biggest that U could be would be, well, what if we go all the way across the river with the pipe? That means V is equal to 0 and U equals 5. And that probably is not the most economical way because we're laying down pipe across the most expensive part, the expensive price for the entire way. So it looks like U should be somewhere between 0 and 5. So we're going to have to test that in our candidate test. So minimize the cost. Let's find the derivative of cost, C prime of U. Okay, so this is 21,120. And then the derivative of anything squared is 1/2. Sorry, the derivative of anything to the 1/2 power is 1/2 multiplied by whatever is inside the square root to the negative 1/2 multiplied by the derivative of whatever is in the square root, which is 2u. And then the derivative of this, well, when you distribute, this is, 10,560 times 5. The derivative of that constant, or since it's constant, the derivative is 0. And then over here, 10,560 times u, and the derivative of that is just 10,560. So this is our derivative. That looks pretty gnarly. We can do a little bit here. We can cancel out the 2 and the 1/2 to give us something that looks slightly better. That's 21,120 multiplied by u multiplied by the square root of u squared plus 9. Oh, not multiplied by the square root. Divided by the square root of u squared plus 9 minus 10,560. So this is not something that you would be expected to solve using the methods of algebra. This is a very intense algebra question. And since this isn't an algebra class, we're going to do something different. So let's take it over to the calculator. And as you can see, I've already substituted that equation into the equation solver. And we just need to take a guess. Let's see, u should be somewhere between 0 and 5. Let's pick 2.5, and let's see if that gives us a answer. Okay, 1.73205. We'll write that down in our work, and we'll come back, and if we're not satisfied that that's not the correct, that there's more than one possible root here, we can substitute another value for u. Let's try closer to 4. And we get that same one. How about 4.9? Notice I'm getting all the way to the other end of the domain here. Yeah, okay, so that's that. Let's go the other direction. What about if we check near 0.1. Maybe there's another critical value. No, we get right to that 1.732. So this is indicative. If every time we try a number, we go right to 1.732, that's probably going to be our only critical value. So with our critical value, we're going to set up our candidate test. Here we've got that candidate test set up in our chart, and let's go to our calculator and try to make this a little bit faster. We're going to start by going into the y equals menu, and we're going to put in our cost function. With our cost function in y1, now all we need to do is come back to the home screen and evaluate y1. So we'll do first, what is y1 when x equals 0? Okay, that's $116,160. Let's do this again. What is y1 when x is 5? Sorry, when u is 5. Okay, that looks like it's more expensive, $123,149. And finally, let's check at our critical value, which was 1.73205. That gets us a cost of $107,671. Let's write all those values down. That gets us $107,671. That's going to be the minimum cost. That happens at that 1.732 miles away from that perpendicular point. And then the maximum cost is going to be $123,149. And that occurs if we go all the way across the river with the pipe. So we can write our summary statement now. So the most economical way to lay down a pipe is to make landfall where u equals 1.732 miles. I should put miles there, according to the diagram. The least cost is going to be $107,000, $107,671. So that's it for our last problem on this practice test. I hope you guys had a good time. I know I kind of had a good time. I love doing all this calculus stuff. And I'll see you next time. Good luck on your Chapter 5 test. I really mean it. I hope you all do the best job you can. And we'll see you next time.